Hey everyone, Matt here from Ekahau, and welcome to the next edition in our Demystifying Wi-Fi series. I am really excited to be here today to talk to you about channel planning. And why am I so excited to talk about channel planning? Because channel planning is probably one of the most crucial, important things that we need to first of all understand, and then we need to implement in our Wi-Fi designs and make sure we've done a good channel plan. That way we can ensure that we've got an optimized, high-performing wireless network. So what I'm going to do in this video today is I'm going to take you through some of the theory around what are Wi-Fi channels, why are they so important, how do they work, and what is the difference between the frequencies that we are looking at. And once I've gone through some of the theory with you, I'm then going to show you some demos inside of our amazing tool, Ekahau Pro. So first of all, let's cover that theory. In Wi-Fi, we use frequencies, and inside of those frequencies, we use channels. And the specific frequencies that I'm going to be speaking to you about today and the channels inside of them are going to be the 2.4 gigahertz band and the 5 gigahertz band. I'm well aware that there is another frequency band that I'm sure you would love for me to be talking to you about today, but I promise we'll save that for another time. Before we dive in and we start looking at different frequency bands, depending on where you are in the world, you're going to have different rules, different regulations, different amount of channels that you can use. So I know this might be a little bit confusing for you, but always please make sure that you check your rules and regulations with your local regulatory domain. Let's start by taking a look at the 2.4 gigahertz frequency band and what channels are inside of this frequency band. By looking at this graphic, what it seems is we can access through from channel 1 to channel 14. And well, yes, you can use channel 14 if you're based in Japan, but everyone else in the world, we cannot use channel 14. You might be thinking, hey Matt, when I'm doing my Wi-Fi designs inside of Ekahau Pro, I don't even see up to channel 13. And well, that might be because you're based inside of the US, and in the US, you can only use channels through 1 to 11. So remember when I said before, depending on where you are, you're going to have different Wi-Fi channels that you can use and have access to when it comes to channel planning. Now let's try and keep things as simple as possible and use me as an example. So since I'm based inside of the UK, what that means when I'm doing a design for a 2.4 gigahertz wireless networks, I have access to be able to use channels 1 through to channel 13. But does that mean when I'm doing my design, I put my AP1 on channel 1, I put my AP2 on channel 2, my AP3 on channel 3, and my AP4 on channel 4? And we'll note we don't really want to do that. And why don't we want to do that is because in the 2.4 gigahertz frequency band, we have channel overlap. So if we take a look at this graphic, what we see here, we are looking at 20 megahertz wide channels. And if we start by looking at channel 1, what we can see is that channel 1, which is highlighted in green, it really overlaps with channels 2, 3, 4. Now, the only channels that we can see in the 2.4 gigahertz frequency band that do not overlap with each other, the other ones that are highlighted in yellow, which is channel 6, and then orange, which is channel 11. So you may have heard before when we're doing a Wi-Fi channel plan for 2.4 gigahertz, we want to stick to using channels 1, 6, and 11. Now this is because we want to try and avoid as much as possible having too many Wi-Fi radios sharing the same channel. And what does that mean and why? Well, let's take a look. You may have heard that Wi-Fi is an extremely polite protocol, and what do people mean when they say that? That's because typically when you have multiple radios or devices all sharing the same channel, only one device at a time will be transmitting. So all the other devices, if they detect that anybody else is trying to transmit on that channel, they will back off and they will let that device finish transmitting before they will even try and transmit. So what is that threshold that these devices will be listening out for if they can hear another device on that same channel? Now, typically this is at around minus 85 dBm. So why do we say that this threshold is around minus 85 dBm? Because if we take a look at what we now call the game in Wi-Fi, and don't worry, we're not going to go into great detail here because this would be a whole video in its own, but I just want to focus purely on step 2. What happens when a Wi-Fi device wants to access the medium? It has to check to see if there's anyone else trying to use it. And what this means is it's doing what's called signal detect or preamble detect on the channel that is on. Can I hear another Wi-Fi radio device trying to transmit on the channel that I'm using? If it does, it will pause and it will not try and move on to the next step. If it doesn't, then great, it can move on to the next step. So what we really want to achieve when it comes to designing our 2.4 gigahertz wireless networks is limit the amount of Wi-Fi radios that can hear each other on the same channel or an adjacent channel at minus 85 dBm or greater. Before we move on to take a look at the 5 gigahertz frequency spectrum, I just wanted to end the 2.4 gigahertz channel planning with a few final do's and don'ts. There may be some people watching this video who are also from the UK or in Europe who can use channels 1 through 13 in the 2.4 gigahertz frequency band and are saying, hey Matt, we could actually technically do a 4 non-overlapping channel plan by using channels 1, 5, 9 and 13. And yes, that is technically correct, but why do I not recommend that? Because in my experience, I have never gone to an environment when there has been no other 2.4 gigahertz wireless networks around me that were not using channels 1, 6 and 11. So if you're using a 4 channel plan where it's 1, 5, 9 and 13, but everyone else around you is using channels 1, 6 and 11, well, this is going to be causing adjacent channel interference for your wireless networks and their wireless networks, which is way worse than co-channel interference. So please just stick to the 1, 6, 11 channel plan and you'll have a better experience on 2.4 gigahertz. It is also possible that we can bond our Wi-Fi channels together. 2 adjacent 20 megahertz wired channels together can be bonded to make a 40 megahertz wired channel, which will allow you to have faster data rates. But let's talk about when we should do this in 2.4 gigahertz. And the answer is never, ever do this in 2.4 gigahertz. When we take a look at the 5 gigahertz channels, we will talk a little bit more about bonding the channels together and how you can do this in 5 gigahertz. But in the 2.4 gigahertz, where we just simply do not have enough spectrum, we should not be doing this because this is going to really reduce the amount of non-overlapping channels that we're going to have. So please never bond channels together in the 2.4 gigahertz frequency band. Alright, so let's take a look at the 5 gigahertz frequency band, and just like I said before, this really now does depend where you are in the world, because you're going to have access to different channels that you can use. You're going to have different rules and regulations, different transmitting powers that you can use, different rules for indoors and outdoors. So please do make sure that you check with your local regulatory domain about your 5 gigahertz channels, your rules and what you can and can't do. For simplicity's sake, I am going to be pretending now that I am based in the US, and in the US we have actually up to 25 non-overlapping 20 megahertz wide channels that we could use. So if we take a look at this chart, what we see right here, we have it broken down in colors and kind of by rows. So if we go by the rows first, what we can see, like we can do in the 2.4 gigahertz frequency band, where you could bond 2 20 megahertz wide channels together to create a 40 megahertz wide channel. We can do this in the 5 gigahertz band, but we can actually go from 20s to 40s and then 40s to 80s and even 80s to 160 megahertz wide channels. But if we look at the practicality of this, if we was to do that, we go from having 25 non-overlapping 20 megahertz wide channels to 12 non-overlapping 40 megahertz wide channels, down to then 6 non-overlapping 80 megahertz wide channels, and then just 2 160 megahertz wide channels. And from what we've already learned in this video so far, the kind of the aim and the goal of Wi-Fi is we want to limit the amount of overlapping channels we have on our radios as much as possible. Okay, now we've broken it down by the rows. Let's look at the different colors, because inside of the 5 gigahertz frequency band, we kind of break it up into like little mini bands, and what we call the first block is the Uni 1 band, and then we've got the next block is the Uni 2A band, and then the next slightly bigger block is the Uni 2C or extended band, and then finally Uni 3. And what you may be noticing about these bands is that they're in different colors. So why is Uni 1 and Uni 3 in green and the rest are in either blue or yellow? Well, this is because Wi-Fi is not the only technology to be working in the 5 gigahertz spectrum. There is other devices that are working here and technologies, and what you can see here is something that says DFS channels. And what is DFS? And DFS stands for Dynamic Frequency Selection, and this is for radar. And radar has the priority when it comes to working in Wi-Fi. So first of all, if we just take a look at the Uni 1 and Uni 3, these are in green, and these channels are not affected by DFS or radar activity, whereas everything that we see in blue and yellow, they are. So our access points and our client devices, they have to behave slightly differently depending on if they're using a DFS channel or not. So first of all, let's cover what happens if we're not using a DFS channel. Our access point can be switched on, it can be using one of the non-DFS channels in the Uni 1 or the Uni 3 band, and it can broadcast our SSID straight away. Our client devices, they have two ways of finding a wireless network, active or passively. And passively is if they're just listening out for the beacons from the access points to discover the SSID, which can take up to 105 milliseconds, or they can actively go and probe on a channel to find out, hey, is there an SSID that I want to be connected to on this channel? Active scanning is faster than passive scanning, and our client devices can only do active scanning on non-DFS channels, so just the Uni 1 and the Uni 3 band. On any of the channels that are affected by DFS, our client devices, they cannot do active probe requests on those channels. Our access points, where if we were to configure our access points to use one of these DFS channels, they also have to play by different rules. So when they are first switched on and they come online and they want to start using, let's say for example, channel 100, the access point has to wait a little bit of time, check to make sure there's no radar activity before it can start broadcasting the SSIDs. Also, whilst the access point is working on that channel, if it detects that there is any radar activity whilst it's trying to use that channel, it has to move from that channel. It can go to a non-DFS channel or it can go to another DFS channel, but it will have to check to make sure there's no radar activity. All of the Wi-Fi client devices, they have to then move to another access point or follow that access point, depending on if there's any secondary coverage from a nearby AP. And then the access point that was using the DFS channel, it has to blacklist that channel for a period of time before it then can go back and use that channel. So it's really important things for us to know for when we're doing our channel plan in our Wi-Fi designs, because if we're working on a site that is affected heavily by radar activity, then we may not want to use some of these DFS channels. But the way Wi-Fi works these days and how many people are using Wi-Fi, you're going to need that extra bandwidth in most cases and need to use those DFS channels. Okay, let me just cover the do's and the don'ts and the best practices for when it comes to your 5 GHz channel planning before we jump into the demo inside of Ekahau Pro. And just like we've already learned on this video around the 2.4 GHz channels, the same rules applies to the 5 GHz channels, where we want to limit the amount of overlapping channels we have on our 5 GHz radios. Now, we don't quite have the same problem as adjacent channel interference in 5 GHz, but when we start to bond the channels together, and when we've got really wide channels, and if we've got a mix of 20 megahertz wide and 40 megahertz wide and 80 megahertz wide channels, then that is also going to cause us some issues. So we want to watch out for that. The tip here when it comes to bonding channels together for your 5 GHz is use the widest channel you can until you can't. And what I mean by that, if you can have an environment where you've got 80 megahertz wide channels and no co-channel interference, then great, use 80 megahertz wide channels. But if you turn on 80 megahertz wide channels and you've got excessive co-channel interference and the Wi-Fi is suffering, then what you should do is reduce down the size of that channel to maybe a 40 megahertz wide or a 20 megahertz wide channel, so you have less channel contention. And I know that you now might be wondering about, what do I do about these DFS channels? Should I include them in my channel plan or should I not? What do I do, Matt? And well, the answer here is use the DFS channels until you can't. And what I mean by that is that in most situations, we're going to need that extra bandwidth by using the additional DFS channels. But if you're in an environment where your channels are heavily affected by DFS, then what you will probably want to do is either just remove some of those channels from your plan, or you might need to remove them all completely and then stick to the non-DFS channels. Also, if you're working in an environment where you haven't got, let's say, more than 6-7 access points, then what you can do is you can just use the non-DFS channels as well. So that's my tips for the 5 GHz channels. And now I'm really excited because I'm going to show you a demo inside of Ekahau how we can do channel planning. So let's take a look. So here we have our beautiful Ekahau Pro, and it's all ready to go with our predictive model. So what I've done so far is I've imported a floor plan, I've scaled it, I've drawn my walls, I've drawn my coverage areas, and I've drawn my exclusion areas. I've even gone ahead and I've placed some simulated access points, and I know the position these access points are meeting my primary and my secondary coverage, which is really important. But I know that I've got some issues with channel interference, which we need to fix together now, and I'm going to show you just how easy we can do that inside of our awesome tool Ekahau. So let's take a look. By default, all of our access points, they're placed on channel 1 on 2.4 GHz and channel 36 on 5 GHz. So what I want to show you right now, if we're looking at the 5 GHz, what we can see is that we are meeting our primary coverage requirements. I'm very happy with that. And I'm also meeting my secondary coverage requirements everywhere. Beautiful, perfect. But what we can take a look at now is if we look at the channel interference view, we can see that it's grey everywhere. And if I hover my mouse over a point on the floor plan, what we can see here is that we've got co and adjacent channel interference of up to 7 radios. So we kind of want to fix that. So I want to show you a few ways that we can fix channel interference by doing different ways of channel planning inside of Ekahau. So first of all, what I want to show you is actually there is another view we can see if we're meeting our requirements or not and what the problems are. And that view is called the network health. So if I come down to here, we can see that our network is right now failing, and this is because we've got far too much channel interference. And if I go to another view, which is the network issues, this is going to show us in color now. Everything is pink. This means that we've got channel interference. So we need to fix the channel interference with our Wi-Fi design. I'm going to go back to the channel interference view, and then let's take a look at some of the ways that we can fix the channel interference. First of all, focusing on the 5 gigahertz. So what I can do, if I select this AP, I want to edit this channel. One of the ways that I can do that is by right clicking on here, edit access point, and it's going to pop up this view. And what I can do now is if I go to what's called the radio 2, which is the 5 gigahertz, which is just here. And if I click on this option now, it brings down the option to show me I can move this radio from being on channel 36 to another channel on 5 gigahertz. So I could move that to say, let's say channel 40. And if I hit close, that radio has now changed to being on channel 40. If I want to change the one over here as well, I can select this, edit the access point, and let's say if I move it onto channel 44 and then hit close, oh, we can see some green starting to sneak in now. So this means that we're starting to not have some channel interference in this area. Okay, so if I just move this one as well onto another channel, let's say channel 48, and hit close, we can see that that green area is starting to get bigger and better. Okay, there's another couple of ways that I can do this. If I expand this view over here, and let's say I want to change this access point, I can actually come to it on this view on the left hand side and change it as well from here directly. And let's say if I want to pick channel 52, that has now changed this 5 gigahertz radio on this access point to be on channel 52. And what we can see from this pop-up is that our current adjacent channel interference has gone down from 7 down to 4 by moving these radios onto a different channel. So if I just continue on and let's say move this one as well from being on channel 36 to say channel 56, and then we've got this one over here, I can change it to be on, let's say, channel 64. And then we've just got 2 more to go. If I change this one as well to say, let's be on channel 149, and all of a sudden our whole floor plan has now gone green, which is amazing. We've got no channel interference on our 5 gigahertz network. Okay, we're going to have some on 2.4 still. So we could do the same approach to go ahead and try and fix the channel interference on the 2.4 gigahertz by doing it in the way that I just showed you. But you know, that took a little bit of time, and there's a much cooler, much faster way that we can do that. So what I'm going to do is I'm going to just close this expanded view. And what I'm going to do is I'm going to click on this button up here. If I hover over for 1 second, you'll see this is the channel planner view. If I click on this right now, what I get up here is the automatic channel planning tool. And what this does is going to automatically plan the channels for all of our access points at the same time. If I wanted to do it just on one frequency band at a time, I absolutely could. But what I want to do is I want it to change the channels for the 2.4 and the 5 gigahertz at the same time. And there's a really cool button here that says disable any unnecessary 2.4 radios. So just remember that for one moment, and we'll take a look at that in a few moments time. The other option here we've got for our 5 gigahertz channels is we can select what channel width do we want to use. So by default, it's going to be 20 megahertz, but we can make it 40 megahertz. But then you see here the selection shrinks down. And again, we can go from 40 megahertz to 80 megahertz, and it's going to reduce the amount of channels that we can have access to. And we can go up to 160 megahertz, and it just gives us those 2 channels. Let's go to a 40 megahertz channel plan and see if we can make 40 megahertz wide work in this environment. The other thing that we can do as well is we can unselect some of the channels. So let's say that we know some of the Wi-Fi radio channels in 5 gigahertz is affected by DFS in this environment. What I could do is I could come into here and unselect some of those known and affected channels before I create my plan. So I'm going to exclude these ones for now. And what I'm going to do is I'm going to click on create a plan, and let's see what happens. So now on 2.4 gigahertz, we have now got no channel interference, and it has automatically disabled some of those 2.4 gigahertz radios. And if I go to the 5 gigahertz, what we can see here is that it's also got no channel interference by using a 40 megahertz wide channel. And I know that this is a 40 megahertz wide channel because it says here 44 @ 40, so this is using a 40 megahertz wide channel. That really is just how easy it can be to do channel planning inside of our awesome tool Ekahau Pro. You can have real granularity and do a manual channel plan if that's how you like to do channel planning, or you can use our awesome automatic channel planner where it can design a high performing wireless network for you automatically like you saw in that demonstration. So I really hope in this video we've learned some basics around Wi-Fi channel planning and then how you can use that knowledge inside of our awesome tool Ekahau Pro to meet your requirements for your wireless designs. I hope you've enjoyed this video and I'll see you on the next one.